Well, hey everybody, Mr. Reeves back with you, and in this video we're going to look at solving one-step algebraic equations. I remember in a previous video on introduction to algebraic equations, we said that an equation was a statement where the left side was equal to the right side. That would make it a true equation. And an algebraic equation was when you had an algebraic expression equal to a constant, or sometimes you have an algebraic expression equal to another algebraic expression. And for an algebraic equation, usually our goal is to find the value of the variable that makes it true, to figure out what value, in this case of x, when you add it to 2, you would get 6. And of course, we said that was 4. All right, now we're going to be looking at one-step algebraic equations, all right? So when you have just one step in an equation, it can be either addition and subtraction, or it can be multiplication and division. All right, but whether it's addition or subtraction or multiplication or division, all right, we are going to be using something called inverse operations. And if you watched my video on different representations of algebraic equations, we had that balance beam model. And remember, we had to do the same thing to both sides. We also did the same thing to both sides when we were using the algebra tiles and the hanger model. When you're solving an equation, you always do the same thing to both sides. And to get the value of that variable, we want to get that variable by itself. So we're going to use inverse operations. All right, so the inverse of adding is subtracting, and the inverse of subtracting is adding. So if you take a look here, they've got 7, and if you start with 7, if you add 3 and then you subtract 3, you get back to 7, because 3 minus 3 is 0. So 7 plus 3 would be 10. 10 minus 3 gets us back to 7. So adding 3 and subtracting 3 are inverse operations. If we started with 5 and then we subtracted 2, that would give us 3, and then if we added 2, we'd get right back to 5. So subtracting 2 and adding 2 are inverse operations. All right, so inverse operations get you back to where you started. All right, so if you take a look at here, we've got k plus 22 is equal to 29. So if our goal is to get that k by itself, we want to know what that k was before we added the 22. So we're going to use the inverse of adding 22, which is subtracting 22. So you can see right here they had k plus 22. They subtracted 22 on this side. But remember, whatever you do to the left side, you have to do the right side, because you have to keep that equation true and balanced. So when we do that, we get k is equal to 7, because 22 minus 22 is 0. So that gets the k by itself, and 29 minus 22 is 7. And if we check our work, we can see that 7 plus 22 does give us 29. 29 is equal to 29. It made a true equation. Therefore, k equals 7 is the solution. Remember, the solution is the value of the variable that makes the equation true. The solution is the value of the variable that makes the equation true. All right, so they give us an equation here that has subtraction. P subtract 18 is equal to 3. Remember, our goal is to find out what P is. What was it before that 18 was subtracted? So what are we going to do? Well, the inverse of subtracting 18 is going to be adding 18. So we add 18, but remember, whatever you do to the left side, you have to do the right side to keep that equation true and balanced. And what do we get? We get minus 18 plus 18, that part is 0. We get p by itself. 3 plus 18 is 21. P is equal to 21. And of course, we're going to check our work. 21 minus 18, does it equal 3? That's what that question mark's for. Does it saying, does it really equal 3? Does it give us a true equation? It does. Therefore, P equals 21 is the solution to that equation, because it is the value of the variable that makes the equation true. All right, so just a reminder here, if you have a one-step addition equation, you're going to use subtraction because that's the inverse of adding. If you have a one-step subtraction equation, you're going to use addition. All right, so take a look here. We have y plus 6 is equal to 52. Well, if our goal is to get that y by itself to find out what it was before we added 6, what should we do? Should we add 6, subtract 6, or add 52 to each side? Well, what we want to do is subtract 6 because it's the inverse of adding 6. Remember, our goal is to get that y by itself. We want to make that plus 6 go away, so we're going to subtract 6 from each side. Oh, there was another choice I didn't see there. All right, after we do that, what's going to happen? All right, so let's go ahead and take a look at this. I'm going to go ahead and try to write this down here. So I'm going to rewrite the equation that I have right here. Y plus 6 is equal to 52. So what did we say that we wanted to do? We wanted to subtract 6 from each side. All right, so when we do that to both sides, what happens here? These inverse operations cancel each other out, and we get y is equal to, well, 52 take away 6 is equal to 46, right? And if we want to check that answer, all right, because that's a good idea, we want to know, does it make that equation true? So we know that y plus 6 equals 52. That's true because that's what they gave us. All right, now I'm going to put 46 plus 6, and then I'm going to put that question mark because I'm not sure if it's actually true. 46 plus 6, well, when I add those together, 6 plus 6 is 12, right? So I get 52 equals 52. It checks. Yes, it gave us a true equation. So the answer we were looking for was 46. So I'm going to go ahead and put 46 in there and check it, and we can see that we did it correct. All right, what about this question right here? 3 plus y is equal to 27. Okay, again, my goal is to get this y right here by itself. What's the inverse of adding 3? Subtracting 3. Remember, you're working on the variable side. We don't want to take away 27. We certainly could do that, but it wouldn't be helpful. All right, so again, now if we go to this equation right here, we have 3 plus y equals 27. And what am I going to do? I'm going to subtract 3 from each side. I'm going to subtract 3 from each side, and when I do that, these cancel, and what do I get right here? I get y is equal to 24. And then if I were to check it, all right, here we go. All right, 3 plus y equals 27. That's our true equation they gave us. Does 3 plus 24 question mark equal 27? Well, guess what? 3 plus 24 is 27 equals 27. It's true. It checks. So the answer to our equation, the solution, was y is equal to 24. Y is equal to 24. All right, let's do one last question here, okay? Whoops. Here we go. Sorry about that. T minus 13 is equal to 35. Again, the goal is to get that t by itself. What's the inverse of subtracting 13? How do we find out what t was before we subtract 13? We're going to add 13 to each side. All right, so here we go. So here's my equation. T minus 13 is equal to 35. What am I going to do here? I'm going to add 13 because that's the inverse or the opposite of subtracting. That's going to get that t by itself. These undo each other, and what do I get? I get t is equal to, what's that? 48. All right, and then we're going to check our answer, aren't we? So here's our true equation that we started with, and we want to know what value of t there will make it stay true. All right, so we're going to try 48. 48 minus 13 equals 35, question mark. Well, 48 minus 13 is 35 equals 35. It checks. So the solution to this equation, the value of t that made this equation true was 48. All right. Awesome. Okay, let's actually move on now to multiplication and division equations. Again, we're just sticking with one operation now. In the first grouping, we looked at equations where the one operation was either addition or the one operation was subtraction. Now the one operation is going to be multiplication and division. But guess what? All right. We're going to do the same thing to both sides. Now, if you remember that video where we looked at visual representations, all right, when you have multiplication, you can't take something away. What did we do? We divided them into equal groups. All right, so the inverse of multiplying is dividing, and the inverse of dividing is, that's right, multiplying. Okay, so take a look here. 7 times 3 divided by 3. Well, 7 times 3 would be 21, and 21 divided by 3 would be back at 7. So multiplying it by 3 and dividing by 3 are inverse operations. All right, 8 divided by 4 would be 2, but 2 times 4 gets me right back up to 8. So dividing by 4 and multiplying by 4 are inverse operations. Okay, so just like adding undid subtracting and subtracting undid adding, multiplying is going to undo dividing and dividing is going to undo multiplying. So take a look at this equation. It's 6t equals 54. And remember, 6 is the coefficient, t is the variable, and when you have a coefficient in front of a variable, it means multiplication. All right, so again, our goal is still to find out what t is. What is t before I multiplied it by 6? So what am I going to do? I'm going to divide by 6. You can see they divided both sides by 6. Remember, because whatever we do it to both sides to keep the equation true and balanced. And what is 54 divided by 6? It's 9. And of course we check our work. 6 times 9 is 54. So t equals 9 is the solution. 6 times 9 is 54. All right, what about a division one? I have to say these ones are kind of tricky sometimes for students. All right. X with that line under it and a 5 means x divided by 5. All right, so again, our goal is to find out what was x before it was divided by 5. Well, x before it was divided by 5, we can find that by multiplying both sides by 5. That's right. We're going to multiply both sides by 5. And when we do that, we multiply the left side by 5 and the right side by 5. Well, 5 divided by 5 is 1. Again, these undo each other. They cancel each other out. So I get x is equal to, and 7 times 5 is 35. So the inverse of dividing by 5 was multiplying by 5. Again, if we check our work, 35 divided by 5 is equal to 7. Okay, so when you have a multiplication equation, remember a number in front of a variable, that means multiplication. You divide because division is the inverse of multiplying. And when you have division, remember that line making like a fraction, that means division. You multiply by whatever's in the denominator. All right, so let's do a few of these problems, and then we're going to be done with this video, and you will get a chance to do some practice. See what you've learned. All right, so this 8w equals 72. This is 8 times w. What is the inverse of multiplying by 8? It's dividing by 8. And again, we're always working on the side with the variable. So we're not gonna be dividing or multiplying by 72. We're gonna be dividing or multiplying by 8. In this case, we're gonna divide by 8. So let's do that. We have 8 times w is equal to 72. All right, I'm gonna go ahead and divide both sides by 8. All right, and when I do that, all right, these are going to cancel. 8 divided by 8 is not 0. 8 divided by 8 is 1, but that gives me the w by itself, and 72 divided by 8 is 9. So w is equal to 9. That's our solution, but of course, what are we going to do? We're going to check our solution, aren't we? We have 8 W is equal to 72. All right, that's our true equation. We want to keep it true. All right, the question is, does 8 times 9 equal 72? Guess what? It does. 72 equals 72. So our solution was W is equal to 9. W equals 9. 9 is the value of W that makes that equation true. All right. W times 5 is equal to 55. Notice they put the 5 after the W, so they had to put a dot. Another way they could have written the same problem would be 5W is equal to 55. Those are equivalent equations. All right, but they chose to write it that way. So what do we want to do? What is the inverse of multiplying by 5? Well, it's dividing by 5. Again, we're trying to get the variable by itself, so we're working with the inverse of this side, not the inverse of what it's equal to. So what happens when you take W times 5 equals 55 and you divide both sides by 5? What happens, ladies and gentlemen? Well, 5 divided by 5 is 1. That's going to get that W by itself because they're inverse operations. 55 divided by 5 is 11. So we believe that's our solution. How about we check it? Well, our original true equation was W times 5 is 55. We want to know, does 11 keep it true? Here we go. 11 times 5 is, guess what? 55 equals 55. You know what I forgot? I forgot to put that question mark right there. All right. Is that true? It is true. So our solution is W is equal to 11. 11 is the value of W that makes that equation true. I hope they gave us a division one this time. Excellent. Here we go. A divided by 4 is 18. Remember that line means divide. What's the inverse of dividing by 4? It is multiplying each side by 4. All right, so we're going to multiply each side by 4. That's what we're going to do first. Now let's see what happens when we do that. A divided by 4 is equal to 18. The inverse of dividing by 4 is multiplying by 4. All right, so when I do that, again, these are going to cancel. And what do I get? I get A is equal to, well, 18 times 4. Well, you know what? That's the same as 9 times 8. That is 72. 72. Now, of course, we think we have our solution. So what are we going to do? We're going to check it. Well, we know that A divided by 4 is 18. That's our true equation that they gave us. The question is, does 72 keep it true when we put it in there? 72 divided by 4, does it equal 18? And guess what? It does equal 18. 18 is equal to 18. It checks. So our solution is A equals 72. A equals 72. All right, so there you go, ladies and gentlemen, boys and girls. That is solving one-step equations. So if you have a one-step equation with addition and subtraction, all right, if it has addition with the variable, you're going to subtract. That's the inverse operation. If it has subtraction, you're going to add. If it has multiplication, you're going to divide. And if it has division, you're going to have multiplication. Using those inverse operations will allow you to successfully solve one-step equations. All right, until next time, have a great day. Bye.